Hello all, so this is a tutorial on Word2Vec and the text embedding. So at first we'll look at the paper for its architecture and then we'll implement it. This tutorial will be mostly applied, so let's dig in. So this is a famous paper of Word2Vec by Google. So they have proposed a novel architecture for representing the words in the vector form, and the words representations are evaluated based on the word similarity task, and the proposed models are evaluated based on different types of, say, state-of-the-art neural networks model previously stated. So let's look at the two architectures that they have proposed. So they have proposed two architectures, namely CBAO and the skip-gram model. So in the continuous bag of words model, they have made a slight modification than the earlier architecture, that is the neural net language model. So in the neural net language model, there is a nonlinear hidden layer was there. So in this CBAO model, this layer has been removed, and projection layer, the projection layers weight vectors are shared across all the words, and they are averaged at the end, and then after that a linear layer has been added after the projection layer, and after that the softmax layer has been applied to get the probability distribution of the words. So let's look at the pictorial representation of the two models. So at first the text of the corpus are tokenized into the words. So based on the in the CBA model tells about the based on the context words, the center words is to be predicted, and and for the skip-gram model, just the opposite case of the CBA is happening. So based on the center word, the context words needs to be predicted. Let's not waste the time and let's just jump to the code right in. So this is the text that I have chosen. So at first I have to initialize a tokenizer to tokenize this text. So this is the tokenizer function that I have initialized, and let's tokenize the text. And at first I'll lowercase the text. So let's check the length of the tokens. Oops. Okay. Now it should work. Yep. So then after tokenization, we need to pre-process the text to get the words and their IDs. So this is a Word2ID. There is a dictionary which represents the word and the IDs and its correspondence. This vocab, it is a set which contains the unique words in our corpus. This will be so our function is complete and our text is pre-processed. So let's call the function. let's check the size of our vocabulary. So we have 81 unique words in our vocabulary. So we have our text tokenized and we have got our vocabulary and its size. So we'll implement the CBA model, for instance. Now we have to, next task is to, we have to create the training data, and for this I need to show how the text is processed. So let's look at an example. So for this example, for the center word and the context words for one distance apart, which is cats and dogs, these are our inputs that you can see in our X column, and Y, this is the center words, this is our target column. And for this we have considered the window size is 3, and for this we have to divide the window size by 2 to get the neighborhood of the center word. And then we are going to the code then. So let's create that data. So this function will produce the inputs and its label, corresponding label, vocab size, and this will take 4 arguments. Window size, which is again a hyperparameter. This xi is the indices of our center word, and IDs will store the indices of our context words. This is for the right neighborhood. We need to implement this function in future. So again, like I've said, I am implementing it for the SIVA model. So if you are planning to implement the Skipper model, the X and Y will be interchanged. this will return the one-hot representation of a word. So our functions are ready. Let's take the window size as 5. Ideally the window size is odd for the ease of use. Let's check. So let's check the shape of the X. And then let's define the Word2Vec class. It will be inherited from nn.module. First layer will be an embedding layer of dimension, vocab size, cross embed size. And second layer, so this embedding layer is the projection layer that is mentioned in the paper, and the second layer will be the linear layer that is also mentioned in the paper. So the layers are initialized. Then we'll have to implement the forward function. First layer, it will be X. Then we have to average it across the second dimension. And then we'll pass this to our linear layer. So our model is ready. I need to initialize the model. Vocab size cost. I have taken the embedding dimension as 2 for the sake of representation. You can take embedding dimension of your choice. The epochs I have taken, say 1000, and learning rate as 4, and criterion will be cross entropy loss. And because of the cross entropy loss for the NN function, NN model, we don't need to explicitly use the softmax activation function. This will take care of the softmax activation. We'll use the add-on optimizer. Parameters, and it will be learning rate. So now we have to train our model that we have defined. These are basic neural network model. So for this we don't need any GPU access. So training is started. The training is really very fast because the model is really very simple. Yeah. So, and for our conclusion part, we have to extract the weights from the embedding layer, and for this. Let's look at the dimension of this embedding widths. Yeah. So this is the embeddings that we want, and because the embedding dimension is 2, you can see the final representation of the words will be the vocabulary size cross the embedding size. So let's visualize the tokens. I am embedding the word and its corresponding word embeddings. Okay, I made a mistake. So let's look at a sample words and its representation. Okay, cows. This word has its embedding vector is this. So let's plot our tokens. So this is our x, and we need our y's as a second argument of the tuple. Okay, just copying this code. This plt.text will label the text, label the points, I mean. Okay, we need to explicitly mention the fixed size argument. Cool, great. So finally we have our representation of the tokens. So in this representation you can notice that there are 3 words. Cow, Hindu, worship. These similar words are closer to each other, and there are also 2 similar words like mata and
mother, these two words are also closer to each other, but you can notice there are many dissimilar words. um, uh, those are in their respective vicinity. uh, for because it may be a reason for the model being too simple. So here the codes, you can play around with it to change these hyperparameters and change the optimizer and the epochs and so on. And this is a simple tutorial to be understandable by anyone at any level. um, so I'll be back again in the future, coming up with similar kind of tutorials. So let me know in the comment section below how much you like this video, and thank you.